Question 347. A particle moves on the x-axis and the graph of the particle's velocity v of t at time t is shown above. It's right here. The graph has a horizontal tangent at t equal 1, 4, and t is equal to 6. The question is, in which of the following intervals is the particle moving in positive direction? Okay, remember the particle is moving in positive direction whenever its velocity is positive, right? Here we have a velocity graph, right? It is a positive whenever velocity is above t-axis. So right over here, the velocity is positive. So t interval has to be between 5 and 7, right? So the answer has to be D. Question 348. In which of the following intervals is the speed of the particle increasing? Okay, the speed of the particle increasing when velocity and acceleration have the same signs, either positive or negatives, right? Okay, also the acceleration is equal to the derivative of velocity, v prime, right? So when acceleration is positive, velocity is increasing then. When acceleration is negative, then velocity decreases, right? Because the acceleration is the slope of the velocity curve, right? Here we have a velocity curves, right? Okay, it is negative here, 0, negative, 0, positive, 0, negative, right? It's also decreasing, increasing, decreasing, increasing, decreasing, right? Now we're going to draw number line using rulers here to here. Okay, so this is a time t starting from 0. Here's the velocity. Down here is acceleration. Okay, velocity is negative from 0 to 2. Let's see, here's a 2. Here's a 4, 6. Let's see, here's a 7. So we have a 5, 3, 1. Okay, so from 0 to 2, velocity is negative. 2 to 5, it is also negative. 5 to 7, positive. 7 to infinity, negative, right? What about acceleration? Acceleration is negative from 0 to 1, right? Because the velocity is decreasing. So negative here. 1 to 2, since the velocity is increasing, acceleration is positive. 2 to 4, velocity is decreasing, so acceleration is negative. 4 to 6, velocity is increasing, positive. 6 to all the way to infinity, that's negative because the velocity is decreasing, right? So we have to look for the intervals where both velocity and acceleration have the same signs. So here, right? Negative, negative, this interval. And also, let's see, 2 to 4, right? 2 to 4. Okay, 2 to 4, 2 to 3 actually, and 3 to 4. And also 5 to 6. Here we have a positive, positive. And when t is greater than 7, both are negative, right? So same sign, 0 to 1, not this one. 2 to 4, here, this one works. 4 to 6, no, right? 4 to 5, they have different signs. 6 to 7, no, right? So the only possible answer can be the answer choice B, right? Question 349. At what time t is the particle farthest to the left on this time interval? We know that when velocity is positive, the particle moves to the right, right? When velocity is negative, the particle moves to the left, right? So let's look at this position line. This is the x-axis. Okay, here's the positive, here's the negative direction, here's the 0. Okay. Look at our velocity curve. It is negative from t is equal to 0 to t is equal to 2, right? So the particle moves to the left. So let's say the particle starts to move at this position right here when t is equal to 0. So it moves to the left. Let's say the particle is at this position when t is equal to 2. When t is equal to 2, the velocity is equal to 0, right? Which means the particle stops. From t is equal to 2 to 5, velocity is negative, right? So it moves to the left again. So at this position, let's say t is equal to 5. Okay, when t is equal to 5, velocity is equal to 0 again, it stops, right? And from 5 to 7, velocity is positive, right? So now the particle starts to move to the right. So let's move to the right, like this, right? So at this position right here, t is equal to 7. So the question was, at what time t is the particle farthest to the left? When t is equal to 5, right? So the answer has to be when t is equal to 5, right? Question 350. If the position of x when t is equal to 6 is equal to -1, which of the following statement must be true about the particle at t equals 6? Okay, let's draw our position line here. Okay, this is our x of t. Here's the positive direction, negative direction. Let's say here's a 0. Okay, when t is equal to 6, our position is -1, right? So let's say here's a -1. So at time t is equal to 6, the position is right here. Okay. If we look at our answer choices, the particle is moving toward the origin, moving away from the origin, right? Okay. When t is equal to 6, our velocity is positive 3. If a velocity is positive, then the particle is moving to the right side, right? So it moves to right side, right? So actually the particle is moving towards the origin, right? So eliminate C and D. Moving toward the origin, right? But is it at an increasing speed or at a constant speed? Okay, the particle speeds up when the velocity and acceleration have the same sign, right? So we know that velocity is positive, right? What about acceleration? Acceleration must be positive here in order for the particle to speed up, right? At a constant speed means there's no change in velocity, right? That means acceleration has to be equal to 0. Does that make sense? Constant speed, no change in velocity with respect to time t, which means acceleration is equal to 0, right? In this graph right here, Acceleration is the slope of a tangent line, right? Because acceleration is the derivative of velocity, right? So at time t is equal to 6, we have a horizontal tangent, right? So slope of this tangent line, which is acceleration, that is equal to 0, right? Since acceleration at time t is equal to 6 is 0, the particle is moving at a constant speed, right? So the answer must be B. Okay? Question 356. A particle moves on the x-axis so that at any time t is greater than or equal to 0, its position is given by x of t and its derivative is given by this, where a and b are two different positive constants. For what value of t in terms of a and b is the particle's acceleration is equal to 0? Here we have a position x of t and its derivative is given right here, right? The derivative of position is velocity, so this must be velocity. And we are looking for the value of t in terms of a and b, where the particle's acceleration is equal to 0, right? So acceleration is derivative of velocity, so v prime, right? So let's differentiate this function right here. V prime is equal to, we have to apply the product rule, right? Derivative of t minus a, that's going to be 1 times 3t minus b plus t minus a times derivative of 3t minus b, that's 3, right? And set that is equal to 0, right? So 3t minus b plus 3 times t, 3t minus a times 3 minus 3a is equal to 0. So we have 3t, 6t is equal to negative b minus 3a is going to be 3a plus b, right? So t is equal to 3a plus b over 6. So when t is equal to 3a plus b over 6, our acceleration, which is the derivative of velocity, is equal to 0, right? So the answer has to be B. Question 371. Daniel's truck starts to accelerate by pressing the accelerator pedal while stationary, and the table above gives the distance x in feet that a truck has traveled at selected times of t in seconds. If both the velocity and the acceleration of the car is negative for t is between 0 and 4, which of the following could be the velocity of the truck in feet per second at time t is equal to? The key phrase is that both the velocity and the acceleration of the cars are negative, right, in this interval. So let's draw the graph of x roughly, and we will think about the velocity and the acceleration. So here is time t, and this y-axis is our x of t, the position or distance. Okay, when t is equal to 0, it's a 200. So let's say here is 100, here is a 200. So coordinate point is right over here. And when t is equal to 4, 1, 2, 3, 4 here, x is negative 320. So negative 100, negative 200, 300 here. So negative 20 somewhere here. Okay, so somewhere right over here, right? Here it says velocity is negative. That means the position curve has to decrease, right? And also acceleration is negative, right? That means this position curve has to be concave down, right? So let's draw the graph lovely. Decreasing, concave down, that's gonna be like that, right? Okay, so we're trying to find the velocity of the truck at time t is equal to, right? So at t equal to, velocity of the truck. Here we have a position curve, right? So the velocity is the slope of a tangent line at t is equal to, right? So at t is equal to slope of tangent line, it'll be like that, right? That's a tangent line, and slope of this tangent line is v prime 2. I'm sorry, v of 2, right? Because the velocity is the derivative of position, v of 2, right? Okay, so far so good. Here, when x is 1, we have coordinate here, that's 160, right? When t is equal to 1, okay? When t is equal to 3, we have negative 80. So this coordinate right here is negative 80, right? Okay, if we draw the second line that passes through these 2 points, then that's gonna be like that, right? That's the second line that passes through these 2 points, right? The second line that passes through these 2 points, is this, right? So far so good. Okay, obviously the slope of this tangent line has to be between the slope of these two secant line, right? The slope of this blue line, the slope of this red line. Does that make sense? Here, acceleration is negative, right? Acceleration is negative. That means slope is decreasing. Slope is decreasing, right? So slope of this blue line, this secant line, must be greater than this tangent line, but the slope of this red line must be less than this tangent line, right? Okay, let me write this. Slope of this blue line is m1. Slope of this red line, m2. Okay, so let's find the slope of this second line that passes through these 2 points. All right, okay, that's m1. So our m1 is equal to y2 minus y1. That's these two points, right? So y2 minus y1, 80 minus 160 over x2 minus x1, 2 minus 1. So that's a negative 80, right? Let's find m2. m2 is the second line that passes through these 2 points, right? So y2, that's negative 80, minus y1, 80, over x2 minus x1. That's going to be negative 160, right? So our slope of the tangent line, which is this, right? This must be, the value of this must be between negative 80 and negative 160, right? So let me write, we don't have enough space. Let me write right over here. Our velocity at t is equal to 2 must be between negative 160 and negative 80. So the question here, which of the following could be the velocity of the truck at time t equal 2? That value has to be between negative 160 and negative 80. So the only possible answer could be Choice C, right? So answer must be C.